All right, last week, I think I gave a few of you a unit circle if you were here. If you don't have a unit circle and want one, they're by the door, so I don't mind if you go one at a time to get one, or you can get it later, whichever. We're going to finish a small part of 4.2, which dealt with trig identities, and then we're going to move on to 4.4. Hello. All right, in the last class, we talked about
Good morning, Grissom High School. Please rise to the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Now for the announcement.
The Junior Civic Team Club is still throwing varsity basketball t-shirts in Mrs. Minute Room EE2533. Please be sure to get one. Short sleeve and long sleeve are available. Have a great day, Tigers.
Okay, the identities that you see in green, we talked about from the unit circle, how sine of any angle, sine of 5 or 6, sine of 45 degrees, sine of 225 degrees, that is always your x coordinate. So whatever ordered pair is associated with that angle, your sine value is always the x coordinate. And of course, to get cosecant, all you do is flip sine, cosecant, sine inverse. To get the cosine of any angle, 225 degrees, 360 degrees, 720 degrees, so on, it's your y coordinate from the order pair with that angle. Tangent of any angle is your y coordinate over your x coordinate. Secant, remember, is cosine flip, and cotangent is tangent flip. Cosine is your x coordinate. Sine is your y. Yep, hang on, this is wrong here. This should be y, thank you. Y, and then this should be y. Cosine's x, sine y, cosine x. Thank you. All right, your even and odd functions for trig, there's only one even function and it's reciprocal. If you'll recall, in 1.8, we studied even and odd functions, and even function is symmetric with the y-axis. When we graph these functions in section 4.5 and 4.6, you'll see how cosine's graph is the only one symmetric with the y, and its inverse secant. The odd functions are sine and tangent, and they're reciprocals. So all it means for a function to be even, a trig function, cosine of the negative angle is going to come out to be the same thing as cosine of the positive angle. And I gave you an example out to the side. Cosine of negative 30 degrees, if you look on your unit circle, negative 30 degrees is the same angle as 11 pi over 6. And its cosine value, or x coordinate, is root 3 over 2. Cosine of 30 degrees, or pi over 6, its x coordinate is also root 3 over 2. So cosine of a negative angle equals cosine of the positive angle. Same thing with secant. Secant negative angle comes out to be secant positive. If you see the sine of a negative angle, it is equivalent to the opposite sine of the positive angle. So sine of negative 30 degrees, that's negative 1/2. Sine of 30 degrees is positive 1/2, but the opposite of course makes it negative. So odd means if you take the trig function of any angle, any negative angle, it equals the opposite of that trig function's positive angle. You'll see these identities some through chapter 4, but you'll really see them when we start chapter 5. Your basic reciprocal identities, which you already know. Sine is equal to 1 over cosecant, and cosecant is equal to 1 over sine. Sometimes later on in chapter 5 and later on in chapter 4, and in calculus, you'll have to manipulate problems. There may be certain instances where for tangent, you may want to use 1 over cotangent, and vice versa. You have your quotient identities. You will often use tangent as sine over cosine. You'll use this one quite a bit. Tangent is equal to sine over cosine. Cotangent of any angle theta is equal to cosine theta over sine theta. Okay, the last identities we're going to look at in 4.2, these are very profound. You'll see these probably more so than any of the others. And the next 3 are called Pythagorean identities. Sine squared theta plus cosine squared theta of any angle is always equal to 1. So if you have sine of pi over 6 squared plus cosine pi over 6 squared, it's going to be 1 every time. So always look out for this. If you see sine of an angle, the angle is the same, sine and cosine are both squared, they have to be squared. It's always equal to 1, and you don't have to do any work if you'll remember this identity. Okay, there's two more that follow from that main identity. Can anybody tell me one more version? Like if you solve this for sine squared theta or cosine squared theta, what will you get? What will sine squared theta be equal to? One minus cosine squared theta. What about cosine squared? One minus sine squared theta. You will see those two versions as well, as frequently as you'll see sine squared plus cosine squared equals 1. Okay, your next Pythagorean identity, 1 plus cotangent squared theta equals cosecant squared theta. Okay, you also have other versions of this identity that you'll see. If you solve it for cotangent squared, what is that equal to? You get cosecant squared of your angle minus 1. So the last version, if you see cosecant squared minus cotangent squared of theta, it's equal to 1. All right, last main Pythagorean identity, 1 plus tangent squared equals secant squared. And you have two other versions. Tangent squared is equal to secant squared minus 1. Secant squared minus tangent squared is 1. This is number 4 in your 4.2 notes that I posted. In 4.2 Math Lab, you see some problems that ask you to use identities to find other trig values.
I didn't think we needed this box in the office anymore,
Okay.
but I didn't know if you want to keep your piece.
Okay, so number 4, you're given that your angle is greater than or equal to 0, but less than pi over 2. And they give you the sine value of your angle is root 39 over 8. And they ask you to find cosine of angle T. So if you look back through all of your identities, tell me one identity that relates sine and cosine only, because you don't know tangent, you don't know cotangent, secant, you don't know anything else. What's an identity that has only sine and cosine in it? It's one of the Pythagorean. Sine squared of your angle plus cosine squared of your angle is equal to 1. So we have to use this since they only give a sine value to find the cosine value. What quadrant is your angle in? It's greater than 0 degrees, but it's less than 90. So what quadrant? Good, you're in quadrant 1. And notice that sine is positive, so that matches up. When we find cosine, it should also be positive since we're in quadrant 1. Okay, you have to go through, of course, and plug in. So they give you root 39 over 8 for sine, and you're going to square that. So you get 39 over 64 plus cosine squared of angle T equals 1. Subtract 39 over 64. And then when you find a common denominator, 1 will turn into 64 over 64. And that would give you 25 over 64. What's the last thing you got to do to get cosine? You have to square root. So when you square root cosine squared T, you're left with cosine T, which is 5/8. All right, and the next couple of problems, they say use identities to find the value of each expression. Leave your answer exact. In this particular problem, they give you sine squared of pi over 6 plus cosine squared of pi over 6, and they want to know what that equals. Whenever you see sine squared plus cosine squared of the same angle, it always equals what? 1. So we didn't have to do any work. Now, if you don't remember that and recall your identities, then you could look on your unit circle and find the value of sine of pi over 6, which is 1/2. Square that. The value of cosine of pi over 6 is root 3 over 2. Square that. You get 1/4 plus 3/4, which is 1. So when all else fails, you can just use your unit circle values to help you out. Cosine of 2.3 radians times secant of 2.3 radians. What's special about cosine and secant? They're reciprocals. Anytime you multiply a reciprocal to its reciprocal, what do you get every time? 1. So if you multiply 2 and 1/2, you're always going to get 1. If you multiply 1/2 and 2, same thing with trig functions. As long as your angle is the same and you've got cosecant times secant, sine times cosecant, it's 1 every time. Okay, in section 4.4, they extend your knowledge of the unit circle and finding trig function values at any angle. So at angle 785 degrees, at different angles, and they also introduce you to reference angles. All right, one of the main things you're going to be doing in section 4.4 is using right triangle trig that we went over the basics of in section 4.3 to help you find other trig function values. And the way that you do that, they're going to give you some angle theta, and it's going to be drawn in standard position. And if you recall from section 4.1, standard position is simply where you have your starting side on the positive x-axis, and then you rotate either counterclockwise or clockwise to your angle. They're going to give you an ordered pair. So that's going to let you know what quadrant that you're in. And that ordered pair is always going to be at the end of your terminal side of your angle. Now, in the unit circle, it had a radius of what? What was your radius in your unit circle? Radius was 1 in your unit circle. For today, our radius lengths are going to be different based on, of course, what your x and y coordinates are. In most every problem, you're going to have to calculate your radius value by using the Pythagorean theorem or the distance from 0, 0, the origin, to your ordered pair x, y. These are small formulas you can use to calculate all 6 trig values. But in a minute, you'll see when we start drawing our right triangles, you can simply go back to using sine as opposite over hypotenuse, cosine adjacent over hypotenuse. You can go back to using your basic right triangle trig that you remember, or you can remember these formulas. It's up to you. Sine in the unit circle was associated with y. Sine when your radius is not 1 and your angle is anything between or anything greater than 2 pi or negative, sine is still associated with y, but it's over your radius length. Cosine's x over your radius, tangent's y over x, just like it was on the unit circle. Cosecant is radius over y, secant's radius over x. Cotangent is x over y. in any case, your radius is always going to be positive, but in the other cases where you have x and y in the denominator, if you get 0, it is undefined. If you ever wind up with 0 in the denominator, undefined. When you sketch these drawings, your point is going to be r units away from the origin. So you're going to sketch your ordered pair, always draw a line segment connecting it back to the origin. And that's going to be your terminal side. You will form a right triangle by drawing a line segment from that point back to your x-axis. Drawing a perpendicular line segment back from that point to the x-axis. Do you want me to scroll back down? Yes. Okay. More. All right. Zoom, I still need that? Yeah, I see something. All right. Okay, I'm showing you a sketch of what your right triangle will look like in each quadrant. They're going to give you, like I said, you're going to have an ordered pair. So let's say your ordered pair takes you to the first quadrant. You're always starting on the positive x-axis, so your angle would just be rotated to wherever that terminal side is. Your radius length is from the origin to that point. And then you would draw a perpendicular line back to the x-axis from that point. And that is always your y value. The distance from the origin to that endpoint is always your x. So of course the horizontal value is your x, vertical is your y, slanted or the hypotenuse is your r value. if you were in the first quadrant, remember that sine is your y coordinate, cosine is your x coordinate, tangent's y over x. All trig functions are positive in the first quadrant because you have a positive x and a positive y. Okay, in quadrant 2, notice that your angle has been rotated from the positive x-axis counterclockwise to this terminal side that contains your ordered pair. Horizontal is still your x, vertical part is your y. What is negative in the second quadrant? X or y? X is negative in the second quadrant. Therefore, cosine that is associated with x is negative. Secant is negative. Tangent is also negative, and cotangent. Sine and cosecant, which relate to your y coordinate, and it's positive, are the only trig functions positive in the second quadrant. Now I'm going to talk to you about reference angles in a minute, but you can go ahead and take note of that, which we go over in a second too. And quadrant 3, given an ordered pair that takes you to quadrant 3, your angle started on the positive x, rotated all the way to that quadrant, horizontal is x, vertical is y. Since x and y are both negative, tangent and cotangent are your only positive trig functions in that quadrant. Quadrant 4, your angle's been rotated to that quadrant, ordered pair. You've got your vertical distance y, horizontal distance x. Y is your only negative value, and y is associated with sine. X is your positive value, which is associated with cosine and secant. So cosine and secant are the only positive trig functions in quadrant 4. Okay, for this, I'm gonna highlight what you need to write down. So we're gonna talk about reference angles. Reference angles are useful when you have positive angles that are greater than 90 degrees, or you have negative angles and you're wanting to evaluate trig values, trig functions. So if you have an angle greater than 90 or a negative angle, it's very useful to find positive acute angles known as reference angles. So a reference angle will always be acute, which means they are less than what? Less than 90 degrees. All right, your definition of reference angle. If theta is a non-acute angle, which means greater than 90 or it can be negative, in standard position, lying in a quadrant, the reference angle, which you'll see denoted as theta prime, it's the positive acute angle formed by the terminal side of theta and the x-axis. So how you find a reference angle, the easiest way I know to tell you, look at your terminal side. Where's the x-axis? What is your degree measure left over? Reference angle is your positive angle, positive acute angle, theta prime, formed by the terminal side and x-axis. Now, in the directions for some of your problems in 4.4, it will say use a reference angle to find the trig value. You don't have to use reference angles if you don't want to. I'm going to show you how to use reference angles. And if you like it that way, run with it. If you want to simply stick to your unit circle, then you can do it that way as well. Can I move it up a little bit? Okay, why does quadrant 1 not have reference angles? They only ask you to find reference angles if your angle is greater than 90 or it's negative. So in quadrant 1, of course, all of those angles are less than 90. So in quadrant 1, if you, let's say that you find one of your reference angles or your coterminal angles is 45 degrees. Which reference angle is itself? So quadrant 1, all of the angles are their own reference angles. All right, quadrant 2, if you have an angle that lies in quadrant 2, you find your reference angle theta. It's the angle formed by the terminal side and the x-axis. And the way that you can calculate the value, say 180 degrees or pi minus that angle, and it will give you theta prime or your reference angle. Quadrant 3, angle that lies in quadrant 3, you find theta prime, your reference angle, by saying that angle, theta, minus 180 degrees. And it will give you the angle that's left over from that terminal side back to the x-axis. It's always the x-axis. Okay, quadrant 4. How you find your reference angle theta prime, say 360 degrees minus your angle. Okay, our first example, they give you point P, -3, -5. It's a point on your terminal side of theta. Find each of the 6 trig functions of theta. And what is useful and helpful is if you will draw a diagram. What quadrant are you in? You're in the 3rd quadrant. So we got point -3, -5. So it's going to take us to the 3rd quadrant. So just do a rough estimate of where your point will be. You know you're in the 3rd quadrant, so draw a terminal side, mark the endpoint as -3, -5. You're going to draw your right triangle. -3 is your x, -5 is your y. This is your angle. This would be your reference angle. So whatever, the angle is always between your x-axis and your radius or your terminal side. So now that we have our sketch drawn, they want us to find all 6 trig functions of theta. So this is where I was saying you can go back to using basic right triangle trig, sine, opposite over hypotenuse, so on. How do we find the missing side or your radius value? How do you find the missing side of a right triangle? You can either use Pythagorean theorem or they gave you a formula for radius that related to your X and Y coordinate. Okay, so now that we found this side length, let's go through and find the sine, the cosine, tangent of your angle theta. What is the sine of theta? What is opposite over hypotenuse? -5 is opposite. Your hypotenuse was root 34. When you rationalize this, you get -5 root 34 over 34. Cosecant, which is sine flipped, root 34 over -5. All right, let's find cosine. So theta's here. It's your adjacent side over your hypotenuse. So adjacent is -3. Hypotenuse or radius is root 34. Rationalize gives you -3 root 34 over 34. What will the secant of theta be? I would flip this so that you don't have to rationalize. So you should get negative root 34 over 30. A tangent of theta is your opposite side over your adjacent side. -5 over -3 becomes positive 5/3. And cotangent is positive 3/5. Since you were in quadrant 3, Tangent and cotangent are the only positive trig values. Sine, cosine, their reciprocals should come out negative, and they all did. Okay, how do y'all feel about that type of problem? Where they give you your point, draw a line to that point, make your right triangle, use right triangle trig. Did I lose anybody during this process? Or any part of it? Okay, in number 2, based on what you're given, they ask you to find the value of the remaining trig functions of theta. They give you the cosine of theta is positive 1/3. They tell you that theta is less than 360, but greater than 270. So what quadrant are you in? You're in quadrant 4. In which that should match up with cosine being positive unless you're in quadrant 1. Okay, we're in quadrant 4. They give us the cosine value. So you're going to draw a right triangle. Theta is always between the terminal side and your x-axis. That's where your angle is every time. Draw a perpendicular segment from the end of that point back to the x-axis. Okay, so when they give you cosine of theta is 1/3, going back to cosine, basic right triangle trig, they don't give us an ordered pair here, but they do give us the what side and what. Cosine was whatever what. Adjacent, and they do give us the hypotenuse length or the radius length. So this is your adjacent side. This is your hypotenuse or your radius length. So before we can find the remaining 5 trig functions, we have to find this missing side, which is a leg of that right triangle. So you can use x squared plus y squared equals r squared, or a squared plus b squared equals c squared. Doesn't matter. Okay, we're trying to find out what y is equal to. So we have 1 squared plus y squared equals 3 squared. So you got y squared is equal to 8, 9 minus 1, and then take the square root. So y is what? 2√2. Okay, now that we found the missing side, we can find sine, cosecant, secant. You already know cosine. So what will secant be? Secant will be 3. So using your right triangle, let's find sine of theta, which is opposite over hypotenuse, which will be what? This, yeah, the side opposite is 2√2 over your hypotenuse, a radius 3. Going back to those first ratios I had you write down, remember sine was y over r, or you can think about it as opposite over hypotenuse. Now that we know sine, let's find cosecant. So flip that. Rationalize, multiply by root 2 over root 2. And that gives you 3 root 2 over 4. Tangent of theta was y over x, or you can think about it as opposite over adjacent. So 2 root 2 over 1, 2 root 2. And cotangent of theta, you've got, you just take this and flip it. So 1 over 2 root 2. Rationalize, and that gives you root 2 over 4. Okay, you have some questions in MATLAB that test your knowledge of what trig functions are positive and negative in what quadrant. In these examples, let theta be an angle in standard position. Name the quadrant in which theta lies. So in part A, they tell you that sine of theta is less than 0, which means, of course, it's negative. Cosine theta is greater than 0, it's positive. So what quadrant is sine negative and cosine positive? Besides quadrant 1, where's the other quadrant that cosine is positive? 4. It really, I mean, it does matter that they told you sine is negative, but if the other trig function is negative and they give you one that is positive, you're just finding what quadrant it's positive. So part B, they tell you that cotangent is positive, which means tangent is positive. They tell you that secant is negative, which also means that cosine is negative. So if you know that tangent and cotangent is positive, secant and cosine are negative, what quadrant are you in? I think I heard somebody say it. 3. That's the only quadrant besides 1 that tangent and cotangent are positive. All right, last part, we're going to look at how to find reference angles, and I'm going to show you how you can use them to find trig values. Okay, in this example, find the reference angle theta prime. You have a positive angle and you've got a negative angle example. Part A is 665 degrees. I did write steps for you, and I'll post these in your notes. But for our purposes here, I'll just go ahead and go through the steps with you. The first thing you want to do, if your angle is greater than 360 or it's negative, you want to find its coterminal angle. And remember that a coterminal angle is simply an angle that is less than 360 but greater than 0. It's positive. How can I find an angle that's less than 360 and positive? How do y'all remember how to find coterminal angles? You just keep adding or subtracting what? What'd y'all say? What's a full revolution around 360? So you keep adding or subtracting 360. If you have a negative angle, you're going to add 360 however many times to get back positive. If you are positive, then you're going to subtract 360 till you wind up with an angle. So if we subtract 360, I find that my coterminal angle is 305 degrees. So that's the first thing you do, is find a coterminal angle if you need to. What quadrant is 305 degrees in? It is in quadrant 4. So this is 270, this is 360. So we'll draw a rough sketch. So if you draw that angle, positive 305 degrees, how you calculate your reference angle, which is the angle always left over between the x-axis and your terminal side. So I'm looking for this angle measurement. How many degrees is between 360 and 305? 55. So 55 degrees is your reference angle. And if you're in quadrant 4, you wrote down that you always subtract 360 minus your angle measure to get your reference angle. Okay, in part B, you have negative 25/6 pi. If you, and the way that I work in radians, I make sure that this is like under 2 pi, positive 2 pi. And this is definitely not. You get negative 4 point something pi. So you get negative 4.1 pi approximately. Are you going to add 2 pi or subtract 2 pi to find a coterminal angle? It's negative, so you're going to what? You're going to keep adding. How many rotations do you need to add to get back positive? If you add 2 rotations, which is 4 pi, where will that take you? If you find a common denominator, this is going to turn into 24/6 pi. And then that'll simply take you to negative pi over 6. So you still need to add 2 pi to find that coterminal angle. And that's going to be 12 pi over 6. That's going to give you 11 pi over 6. What quadrant is 11 pi over 6 in? In quadrant 4. What is your reference angle that's left over? Good, 30 degrees or pi over 6. You may encounter one that's in radian measure. and 4.7 radians, each quadrant, like for example, if I say 0.5 times pi, this is 1.57 radians, 3.4 radians. This at the bottom was 3/2 pi, so 1.5 times pi in your calculator will give you 4.71 radians. So 4.7 radians is really close to your negative y-axis. It's in quadrant 3. So in quadrant 3, the way you find a reference angle, I'm finding this whole entire angle that goes from that terminal side back to the x-axis. And you're going to say your angle, which is 4.7 minus pi, or 3.14. And so when you do that in your calculator, you get 1.56 radians. So that one's just a little bit different. That's why I wanted to go over that one with you. Okay, very last thing we're going to look at. This is an example of how you would use reference angles to find trig values. Of course, you can use your unit circle to find cosecant of 7/6 easily. I'm not a reference angle fan because I just want to remember my unit circle values, say cosecant of 7/6, I'm finding sine, and roll with it. But just in case you wanted to use this, you would draw a sketch of where your angle is. 7/6 is in the third quadrant. You would then calculate your reference angle, which from pi, which is 6/6, that's pi/6 or 30 degrees left. So your reference angle is pi/6. The way that you use that, you actually only have to find the cosecant of pi/6, which if you find the sine of pi/6 or 30 degrees, it's 1/2. Flip it. Then you have to remember that you are in the third quadrant where cosecant and sine are negative. To me, that's just a lot of work when you could just simply look at your unit circle, find the sine of 7/6, which is -1/2, and flip it. Okay, I think I kept 4.2 open for you in Math Lab. I'm not sure, but I'll double check. I'll make sure it's open so you can finish it and do those identity problems. And then you need to work on 4.4 Math Lab. If you would rather do a paper assignment, I can give you one, but I figure most of you will use Math Lab to do it. Okay.